Alright, so for today I thought, okay, let's try to do some LeetCode problems. But the problem was that in LeetCode you cannot solve the problems in Haskell. And I wanted to go with that as a meme, more or less. And yeah, let's try to solve a problem. I chose an easier one. I think it says easy. We'll see how easy it is. But I have a rough idea of how to solve it. So the idea is that we have some values. In this problem they say they are the sweetness of some cookies. Doesn't really matter, they are just numbers. And we have a value k, which is our threshold. And we have a rule of how to combine said cookies to make them sweeter. And we need to know how many operations we need to make until all the cookies are at least k sweet. And in this one, why I guess it makes the problem simple is that it tells us how to do that. It tells us, well, you have to take the least two sweet cookies and combine them. So it gives us the order. We don't have to sort anything. We just have to find the minimum numbers, combine them with the rule, and that's that. So that's why the problem is simple. If we didn't have that rule, probably it would have been like dynamic programming something. So yeah, hopefully it makes a bit of sense on what the problem wants. So yeah, let's actually try to solve it. So I'm not gonna write the code in the browser. I have the bad habit of pressing Ctrl W to delete words, and yeah, probably I'll close the browser. So let's just make a file, right? And so GCN cookies. I don't remember exactly, so let me just copy some GCN cookies, some other file. So I need to put module main, right, and undefined. So yeah, we'll need to read this kind of stuff. So it's like the number of elements, I guess, the value of k, and then the numbers. Well, we won't even need the number of elements, but that's beyond the point. So we'll need to read two lines, right? So I mean, it won't work with interact, so it is what it is. Let's do it in GHCA because it's gonna be easier to solve it like this. So to get the first thing, we'll probably do something like actually I don't remember how to read the input, but that doesn't really matter. We'll have something like words that we're gonna apply on the string. Let's imagine that we are able to read this string somehow, right? So it splits it into words, and we should be able to pattern match it like nk, like this. I guess I need to use equal, but okay, so we have n and k. We can actually read k, but I think we need to say that should be like string to int. I don't remember if that's how you do it, but so is it like, yeah, strange. Anyway, so we can actually get the number. All right, and for the list, for this list, right, like I vaguely remember using something like this. Okay, so I have to specify the entire type. Yeah, whatever. So this is how I usually read a list of numbers when they are like from LeetCode problems. Anyway, so the point in the problem, as I said, was to find the minimum two numbers, right? So obviously I think we should sort the array. I don't think it's possible to have a min k or something, like smallest k numbers. So I think the easiest way is to use sort. But I think for sort we need data list. And do we have sort? We do have sort. So we have this entire thing. We can use sort and we get the numbers in order. Alright? And we might need some kind of way of getting the first two elements. I was thinking if pattern matching works, probably something like this will work if it's like from a function, but I don't think it works for this. Holy shit, it works for this. Okay, anyway, and the rule was to have something like this, right? This is how we make the new number. So we combine, and here we have x's, which is the rest. So the idea is then to take this thing and combine it with x's, right? And then we have to sort again, split the number again, and do the rule and so on. So quite simple, to be honest, I think. So let's see if we are gonna get it first try. Okay, I'm curious. Haskell read line. I don't remember how to read a single line. Maybe Google will prove to be a better option. So I think I want the IO string. Get line or something. Yeah, get line should do the trick. Anyway, so as I showed you in here, let's say it's gonna be something like n and k, which we don't care about that, the first one. Should I use let? Should I use so map read student and then words and then get line. Let's do like return or something to have it. So get line is oh. Okay, fine. Let's not. But I could probably do something like this, and instead of this should make it work, but it looks kind of ugly. Okay, let's not discuss that. Let's imagine that it was everything with dollars and because pretty much that's what it is, but since this thing returns IO and these work with strings, I should do something like line is equal to this and then use the line, but I'm too lazy to change it, so we'll have to deal with this. And then let's do the same thing. but this time for the entire array, right? So we basically reached this part. So we have to sort and get to elements. I think we could make a function that takes in an array. So what can we call it? Sweeten. Basically, it's like sweeten the array. So it's gonna take in int array and spew out an int array. Someone is gonna say here, did you try to write 7? But you are disabled. So as we saw here, the first rule is gonna be if we have at least two numbers. Like if you don't have two numbers, you are cooked. Okay, and what we have to do here is a plus 2 times b combined with axis. Right, so this is the first rule, or I guess the only rule. I'm curious because the LSP doesn't show us the fact that we don't pattern match on the rest. So I would say that if anything else happens, you should get a -1 because that's what return -1. Okay. I mean, we could I was thinking to use some kind of function that is going to take this function and continue to apply it multiple times, and we could have a rule like something that says, but we also need a number of steps, so we could implement that ourselves, right? So basically solve is going to take in the array, is going to take in the int k, and is going to tell us the number of steps. That's what solve needs to do. So axis and k. And how can we actually apply this thing multiple times? Like right now here we did only one step, right? I guess the step is this. Clearly it's going to be something recursive, and I would like to have a different thing like go, which is gonna do that. Okay, and it should store, either we do it, so it should take in the array because it's gonna change it, or I guess, you know, it's gonna like do something different with it, right? And what else can it do? Like, would make sense to, I mean, if you apply it recursively, like it was going to be called by itself. It also makes sense to return the list of numbers. but I also want to count this thing, like the number of calls. That's why I wanted this kind of A goes to A, and something like A, but that's not it. It's like until or something, a function. Right. Yeah, I think this could work if like the argument of until is the list and the number of iterations. So I can do something like int, right? So this would be the function that just goes multiple times. So it should be like the array and count, and we should probably do sweeten axis and count plus 1. Well, I mean like this. Check is gonna be and return boolean. So check should be something like I'm thinking, so it should return true to go again. So go again is basically I should still take in axis, and I don't care about that. And let's think, when should we stop? So we should stop when we have -1. Is it, can I do it like this? So I guess no, we should stop or should be run, just to make sense that it should run. Let's say should run. So if we have -1, we should stop, and if we have anything else, we want all to be greater or equal than k in axis, right? We want this thing to happen. Okay, so then we can say something like until should run go axis, but this thing is gonna, oh, should I say 0 here? Yeah, this thing like returns int and something, so I want to do fst. Strange. Why would it complain? So should run is int bool. Okay. Yeah. Whoa. The hell? I was looking at this thing. Looks different. So it's should run, clearly it has the type that I want. Go also has the type that I want. So then what doesn't work? what doesn't work. I mean, this one is that, this one is an int. Well, SMD actually. Okay, so then I want to like call to solve, right? And actually print. So print solve x is k. Now, this is gonna be interesting if it works first try. Should we run code or submit code? I mean, yo, first try. Obviously, yeah. I was way too. Holy shit! Even test 0 didn't work. You know what? I forgot to call to sort. Oopsie. I knew something was missing. Import data list. Let's import sort. Yeah, I forgot. Licit. Okay, I forgot to do sort. So when should we sort the array? Well, here. Let me just sort the array. Okay. Let's try again. Oh, but it also got time limit. That's, I mean, you know, Haskell being Haskell, but hey, yo. Time limit exceeded. Boys, we are cooked indeed. We are indeed cooked. So it looks like it should be a formula then, right? Somehow. Damn, I was tricked by the example. Wait, I have Hackos? You know, I don't care. It's clearly something like humongous amount of numbers, so maybe, you know, these cases are the ones that can be optimized, but okay, so it looks like the minimum plus 2 times the next one. So yeah, it would be a good question to figure out what the formula is, right? How many times you have to apply this thing to get the k. So I mean, maybe we can try to not use sort and just try to get a minimum, because, you know, sort is gonna be n log n, and it's gonna be something like n, like the complexity. Not even sure what the complexity is though, because sort is gonna be n log n, but we do this thing, like worst case is gonna be done n times, right? Like for all the elements in the basic. I mean, even if it's n divided by 2, it's still n. So n squared times log n. So it's pretty slow. but we can make it n squared at least if we don't use sort here, because I mean, sure, we could try to do like a heap queue, but come on, there's no heap queue in Haskell. It would be too painful to implement it from scratch. So yeah, maybe let's try to use min. That's like min 2. I gotta be curious if there's a way to get because getting the mean is pretty straightforward. Okay, let's implement the min 2. Min 2 is gonna take in should take in an array of numbers, and it should give us 2 numbers. With where the first minimum min axis, the second minimum is gonna be min, and I do filter not equal to m1 over axis what? Wait. I guess minimum, right? Yeah, and I mean, whatever. We have the 2 minimum ones. And then sweeten is gonna be just the formula then. Or I guess sweeten is gonna be something like if we have an empty list is -1, if we have a single element is -1, otherwise we can say something like let a b is equal min axis in okay, but I need a new axis prime, so that doesn't really work. This prime should be filter. So I want to remove both A and B from the list. So let's say element, I guess X, X is different than A, and do we have end? different than B. Something like this. Because you know, its minimum is not gonna work on an empty list. So that's that, and maybe without sorting. Right. So this is n squared basically. Like if this doesn't work, then we are pretty much cooked. Okay, like timeout that fast? Okay, nice, at least, well, I mean, there is also time limit exceeded. So at least we have some wrong answers, which is good because, you know, I'm really curious about the wrong answers. Oh. I mean, if it's a single element. I mean, you know, I would return -1. But I don't know if until first executes should run and then it executes this. That would be pretty weird. But you know, I mean, if the this test case works, it's like pretty clear that can I compile it? JSON cookies. So we have, I don't know, something at 9 for the first test case. 273 646. I mean, there are numbers that repeat themselves, but that shouldn't matter. So we get 3. Oh, I know why. Because I remove all the numbers that are equal to A and B, not just the first one. Ooh, that sucks. So let's say I do the remove function myself, because okay, so an empty list is an empty list. and here let's say it's y. This thing, oh, I need remove first though. Which should be something like int. Okay, let's not talk about it. So if it's like true, it should return x's, and just that's that. Y's, when it's false, basically, it's gonna do check if x is equal to y, then we well, I don't even need this thing, if I'm being honest. Do I need it? I don't think so. Like if x is equal to y, then I return y's. And otherwise I just do x combined with remove x is y. Weird. Right, this one should remove the first occurrence, and that's it. So like here, for example, I can do remove x is m1, and here remove a, remove b, x's. I guess I want to do it the other way around. It looks a bit better. Okay. So now, if I do the same thing, still a 3. Although here it should do 4 iterations. Oh, yeah. I forgot to recompile. Wait, can I copy paste everything? Okay, so maybe. And this time should be more efficient, I would say. Oh wow. Holy shit, time limit exceeded. Damn, this thing sucks. So pretty sure the first test case is gonna have 10,000, or 10 to the power of 6, is it 10,000? Or is it 1 million? Numbers. So yeah, like a priority queue would be the time for if you remember ds.h. For some reason in ds.h pq I guess I wanted to see the definition of the priority queue. That was the first data structure that I did, which is pretty funny. But honestly, wouldn't really be worth it. Because the problem with Haskell is that even if we did priority queue, it wouldn't even be, I mean, so like right now the complexity is n squared basically. Can we go a bit lower than that? No, I feel like if we would get n log n at least, then things should pass. Because usually for easy problems, I mean that's what's a bit strange, for easy problems n log n or n squared usually works, and it's like medium problems that are n or n log n, and then hard problems are n log n complexity, or I guess log n complexity. So this one, bit strange that it doesn't work. So yeah, this one clearly n steps, and minimum again it's n steps. So we do minimum each time we do a run. I mean, remove doesn't really matter that it's n, because sweeten is gonna be n regardless. So yeah, that's why a priority queue would be nice here, because instead of having to do minimum, we can do minimum using a heap queue, which is gonna be log instead of n. But we could try to sort the numbers and keep them sorted, so that's another thing. So we could try to sort them and keep the numbers sorted. So let's try that. So let me just sort it here. Sort. Right. And my idea is, okay, we try to keep the numbers sorted, right? So we do like sweeten count +1. Yeah, I feel like it could be a formula, but I cannot think about the formula, so Okay, and in here I could try to take the first two numbers. Let's see. So this should be like anything, and here let's say AB. Right, so the question, this thing inside of the array. So right now this thing is complexity of 1, right? So this thing is n log n, right? This thing is basically n, and this until, and sweeten is of 1. So the full complexity is n log n because of this, right? So we need to find a way to insert this stuff into X's, probably with binary search. That would make sense. But let's first try to cheese it and see if insert, so we don't need min. Order. Insert order. Let's see if, so let's say we have a number, empty list, empty list, you know, insert order. So at this point we have two cases: x is smaller or equal than y, then we do x, y, y's, right? And otherwise we do something like y combined with insert order x, y's. Okay, and here insert order so yeah, I know it's still n squared, but my hope is that now it's a bit faster. Oh yeah, I mean, it doesn't work, sad. It looks the same, and maybe it's a bit better, couldn't tell. But yeah, I mean, feels like we are closer. Again, I think we need to do binary search though to insert the number. Oh, well, that's not a thing in Haskell. Ooh, damn. Yeah, this problem, you know, looked like it's possible to do it, but maybe it's not. Like I was tricked into thinking it's doable because of this thing looks nice, right? This solution like this. And this was just like, oh, it's, you know, simple. But it's actually not. And binary search doesn't really work because, you know, accessing elements in an array in a list is linear, so I think this is the best we can do, I think. Which is sad. Well, I guess let's see if damn, I only have Haskell solutions in this one. It's funny. GC and cookies. No, let's try the way that actual competitive programmers do it in Python. So import heapq. I think that's a thing in Python. How do I press heapq, right? Straight from the docs. So line 1 is going to be like input, right? Line 2 is going to be input. No, it's funny, we can do the same thing in Python. And k, and we can do like map int. And for the other one, axis, well, let me just do list just to right. So heapify is a thing, so let's do heapq dot heapify. Wait, yeah. So basically we have the def sweeten. We give it a list of numbers, right? If len axis is smaller than 2, we return -1, like that. Otherwise we take a is equal to axis dot heap pop, I think it is, right? Yeah, heap pop. But heap push pop, okay. I guess it also changes the thing in place, so that's something. And we get C, which is a plus 2 times b, and heap q, heap push. Anyways, I don't know why the LSP doesn't work for Python, but couldn't care less, honestly. Heap push, okay. I guess how do we do the solve? So let's do def should run or something. This one obviously takes in axis, and if axis is equal to -1, false. And even Python has the all thing, so but I don't remember if that's how you write it, so we'll see. I think I also need to pass in axis, obviously. So we have that, and then while should run axis count is equal to 0, count plus 1, and I think return axis. Return axis, right? And I mean here. Oh, you know what? What I didn't check here is if it failed. So maybe like if is equal to -1, print -1 or something, and else do that. Right, like that should be something. Oh, I forgot about the split. I knew something was missing. The fuck, all takes one argument? Well, I need to use a map then. Dude, what? Okay, what? Print text. At least in Python we can print the stuff, so... Dude. Should run. Oh. So this thing doesn't really return anything. I just say axis. Zero. Print axis again. Yeah, sure, why not? And all x greater than, wait, I'm wondering what the fuck this. Oh, it's smaller than, or what? No, let's close the Haskell one. Oh, I have it in okay, whatever. Wait, what? Wait. But that's not true, though. You know what, for x in axis, if x is smaller than k, return true, and here return false. Like this should also work. Okay. So I'm curious, will the Python solution work? Oh, I'm also printing some crap. Where? Oh, here I was printing it. Okay. Hey yo, what the fuck? And it wasn't even that much faster, honestly. usc.hs. So maybe it is something at runtime. So for example, okay, let's think about it. How can we do that? So this one doesn't matter. It's gonna be something like from a list to a list. So we get -1, it is what it is. So should run. This one is interesting. Like, how did that work? That's weird. Should run. All. This one is like greater than k axis, and then it's true. Or is it like, is the result of applying until it holds? Oh, so I should do until, and this one is not should run, is should stop, or like finished. So that was the first problem. And the second problem is that I don't check if this thing is -1. So I should probably do something like case of -1, and something is gonna be -1, and anything else, and the number is gonna be that number. Okay. So it's actually too slow still. But can I have something like 9 and then 1, 2, 3? It gives me 2 because it's like 2 iterations, which is not good. Wait, what? One, two, oh, I guess 1, 2, 3 works then. Okay, so the algorithm is fine. But yeah, it seems like I don't think it's possible to I'm curious, do I have Hackos? Oh shit, I do. Let's try it. I mean, obviously it was a huge text. And let's do I'm curious that if it finishes, I'll be, happy with it, because we don't have heaps in this thing. Also, it would be a -1, but it's, holy shit, 15 seconds at least. So maybe there's a way to check if it fails or not, where you don't even have to sort or anything. So like, for example, is doable, let's say, right? And here, for example, I can do I would have needed the old sweeten, but let's do it again. Because if it doesn't even matter if it's ordered or not, I think, to figure out if it's doable or not. So at least we have that. Okay. So we should have something like go, which does this thing. So this is not doable, this is doable, basically. And now we should do something like if is doable x is k, then this, else print -1. Wait, what? Oh, print -1 like this. JC. Put struct. So it should be a bit faster on checking if it's not doable or not. I guess. So maybe. Huh. Wrong answer, okay. Wait, which test case did I take? I don't remember. Should be unlocked, right? Wait, what the fuck? It doesn't keep it unlocked? Yo, that's crazy. I mean, that was the last idea that I had. But see, like, it's much faster like this. Right, checking if it's possible to solve it and only then solving it. And yeah, it seems like this insert is like, let's check with the Python version. .py. See, like, it's much faster with a heap. So I guess that's the difference between n and log n. Okay, huge difference. But yeah, I mean, you know, actually we were able to solve it even though it was in Python. Yikes, that sucks though. Well, heap queue, I mean, I remember, but it's a separate package. Well, the one that I actually want is pq. But then again, I don't think it's possible to have it. Is it? Data pq. Right. So it's not really possible to use the priority queue, I guess. Damn. I was thinking, what if we just copy the like this one, but I'm pretty sure it has dependencies. So yeah, it's probably we should be happy that we did it with Python. So, well, you know, oh, look, we solved it. Pretty cool. Wait. Okay. Wow, so the test 14 was pretty slow even for Python. But I'm pretty sure 14 is the one that I unlocked and checked. Anyway, yeah. 25 points. Nice. Yeah, but I mean, I'm surprised that this problem required n log n solution. Yeah, I mean, it sucks a bit because, you know, I was thinking of this exact solution and it was looking pretty cool for Haskell, like to use until and the recursive call like this, which changes the list. I was pretty sure that a n squared solution will work, but it looks like it didn't. And to use priority queue, like, sure, we could implement it like this, but it's not gonna run on Hackerrank. So yeah, I mean, you know, at least we saw how to use it or how to solve it with heap queue in Python for anyone who was like wanted to know how to solve the problem itself, like jump to this part and look at the Python code. But yeah, for the Haskell part, I guess this is the best I can do. I'm not sure like implementing a priority queue in Haskell wouldn't really make sense because it requires indexing in the array, like binary search, and that's n, like complexity of n is not linear, it's not constant, it's linear, so that sucks a bit. But yeah, I mean, okay, let's say that we actually, you know, solved it. So yeah, I mean, we'll see in the next one. Let me know if you want, maybe if you have any problems that you think would be cooler. I mean, it was my fault, I didn't see that it says heap here. I guess this is like the kryptonite for Haskell, the heap. Yikes. Yeah, but I mean, maybe if I'll do another one of these, I'll try to find a problem that's solvable. I mean, I don't want to solve it beforehand because then it wouldn't be fun, but maybe I'll try to solve it beforehand and then you know, solve it again, basically. But yeah, I mean, for this one, I had the idea of how to do it, but I didn't think that it would require a heap to solve it because it was easy, and easy problems are, you know, for people that use lists. So yeah, I mean, yeah, we'll see in the next one. So see you.